Hi everyone! In this lesson, you are going to learn how to compare fractions by first rewriting them with common denominators. When fractions have uncommon denominators, meaning they do not have the same denominator, you can compare the fractions by first rewriting the fractions with common denominators. There are three different ways to write fractions with common denominators, and I will say that there is a way that is better than the others. These are listed in order of how you should try to rewrite the fractions 1 through 3. The first way is considered the best way, in my opinion, because it is the least amount of work. The second way is the middle amount of work, and then the third way is the most amount of work. So number 1 says here, one denominator is a factor of the other. A quick example, and I'll go into this in more depth, is the fraction pair 3/4 and 5/8. Because 4 goes into 8 evenly, we would just use 8 as the common denominator, and we only have to change one of the fractions. The second way is called product of the denominators. We know when to use product of the denominators when the only number that is a factor of both denominators is 1. Multiply the denominators by each other, and the product is the new denominator. And then the third way, if the denominators share a common factor other than 1, what you should do is list the multiples. Now let's look at each of those methods in a little bit more depth. Here's the example 3/4 and 5/8. Since 4 goes into 8, 8 is the least common denominator. Also, we only have to rewrite one of the fractions. I usually write these one on top of the other, and then I write the equivalent fractions with the new denominators next to them. So here I have 4 goes into 8 evenly, so I'll rewrite that with an equivalent fraction. I know that I multiply 4 times 2 to get 8, and the rule is whatever you do to the bottom, you do the same thing to the top. So I'll rewrite 3 times 2 is 6/8. Since the bottom fraction already has a denominator of 8, the numerator is 5/8. Now I can compare, and I see that 6/8 is greater than 5/8 because we're dealing with the same size piece now. They're both 8s, but I have more here. The second example we have is 4/6 and 2/9. I know that 6 and 9 share a common factor, so what I'll have to do is list the multiples of each and use the lowest one. So when I'm dealing with this, I know the first question I should ask myself is, does 6 go into 9 evenly? And the answer to that is no. So the next question is, do they share a factor other than 1? So I could actually list out the factors of each. I know the first factor pair of both would be 1 in itself. Now as far as the 6, after 1 comes 2, and I know 2 goes into 6 evenly. I multiply 2 by 3 to get 6, and since that's the next number, I'm done with my factors of 6. When I come over here to the 9 factors, after 1 comes 2, but 2 doesn't go into 9 because 9 is an odd number. 3 comes next, and yes, 3 does go into 9. I multiply 3 by 3 to get 9. And since I now have the same number on both sides, I know that I'm done there as well. So it really doesn't matter what the factor is that goes into both. The method that we use is list the multiples, and we're going to use the lowest multiple as the common factor. So 6, when I list the multiples, I get 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. Now because I know my basic facts, I know I don't need to go any further. This is why knowing your basic facts is super, super important. It makes everything you're going to do from here on out way easier. The multiples of 9, 9 times 1 is 9, 9 times 2 is 18. That's why I stopped. I knew that 18 was also a multiple of 9. The lowest common multiple between 6 and 9 is also the common denominator between 6 and 9. So now we rewrite these fractions as equivalent fractions. 6 times 3 is 18, so I would multiply the 4 by 3 as well. 4 times 3 is 12. My pen does not seem to be working. I apologize for that. Nine times 2 is 18, so I would also multiply this top by 2, and I get 4. Now I can easily see that 12/18 is greater than 4/18 because we have the same size pieces. They're both 18ths, but with 12/18 there are more of them. And then the last way that we would use is product of the denominators. Here's an example. 2/7 and 4/5. The only number that goes into both 7 and 5 evenly is 1. I could list out the factors to figure that out, but again, if you practice your basic facts, you would really start to know that without having to list out the factors. So since they will not share any factor other than 1, the lowest common denominator that you would get for the new fractions is the product of the denominators. The product, remember, is the answer to a multiplication problem. 7 times 5 is 35. The product becomes our new denominator. Now rewrite these fractions with equivalent fractions. Ask yourself, what do we multiply 7 by to get 35? And that would be 5. If we multiply the bottom by 5, we do the same thing to the top. 2 times 5 is 10. And then we go to the bottom and figure out what the equivalent fraction is to 4/5. Since we multiply 5 by 7 to get 35, we would multiply 4 by 7. Whatever you do to the bottom, you have to do to the top. Note, though, what I do to this fraction and what I do to this fraction are two separate things, so you address them separately. 4 times 7 is 28, and here we can see that 10/35 is less than 28/35. So their equivalent fractions, 2/7 is going to be less than 4/5. Once you've found your common denominator and have rewritten the fractions as equivalent fractions, compare the numerators. The greater numerator will be the greater fraction. Let's look at this last example, 4/7 and 8/11. I'm going to write the fractions over here to the side, and I'm going to ask myself those 3 questions. The first question is, does 7 go into 11 evenly? I know the answer to that is no, so I would go to the second question. The second question is, do they share a factor other than 1? Well, I know that these are both prime numbers, so their only factors are 1 in itself. So no, they do not share a factor other than 1. That means I must use the third method, which is to list the multiples of each. Oh, excuse me. So sorry. The third method is not list the multiples of each. The third method is product of the denominators. Sorry about that. So the product of the denominators would be 7 times 11, which is 77. I'll rewrite these fractions with equivalent fractions, and that product of 7 times 11 is my new denominator. Since I used product of the denominators, I know what I multiplied 7 by was 11 because it's the other denominator. If I multiply For this set of equivalent fractions, if I multiply the bottom by 11, I do the same thing to the top. 4 times 11 is basically just 4 times 1 and doubling it. 4 times 1, 4 times 1, 44. Again, since I know that I multiplied 11 by 7 to get this denominator, I would do the same thing to 8. 8 times 7 is 56. And now I know that 56 is greater than 44, so 8/11 is greater than 4/7. I hope this helps you to understand how to compare fractions with unlike denominators. Don't forget there are lots of other resources available on our Schoology page and online, plus ask questions when you need to.